In this notes video, we will be discussing matter and some of its subtopics, atoms, elements, the combinations of atoms, and the states of matter. So let's jump in. So everything around you, including your Chromebook, your hands, and the air you're breathing, are all matter. And the definition of matter is anything that takes up space and has mass. So there are two key parts to this definition that you need to know. Takes up space and has mass. So matter is made up of particles called atoms. And we're going to talk about this here, and we'll keep bringing it up a couple more times because it's a little bit of a tricky subject to wrap your head around. Atoms, they're super duper small. So think of an atom like a Lego block. You always start with that first Lego. You pick up that piece with the 8 little doodads on it, and you put it down and you start building your house or your car, or if you're one of those Lego masters, your giant T-Rex. Okay, you got to start somewhere. The arrangement of those Lego blocks gives you your properties. So if you arrange them in a square, well, now you got a house. If you arrange them in a long rectangle with wheels, well, now you have a car. I used to make like dogs, a giraffe one time. I used to make all kinds of stuff with my Lego blocks. So it's the same thing here. The way we arrange those atoms gives something its property, whether it's a solid, a liquid, or a gas, what color it is, what kind of properties like smell, or if it is explosive or not. All of those things come from how the atoms are arranged. So to simplify, just highlight this part, bold it, underline it, put a square around it. Matter, 1, takes up space, and 2, has mass. So that is what matter is. So look around you. Everything you see around you is matter. The folders, all my stuffed animals, Macaroni the cat, the door, the air, the desk, the floor, your shoes, me, all of you, my plants, all of it is matter. And yes, air is matter. It takes up space and it has mass. And you're going to watch a video that proves that air does in fact have mass. So we're going to talk about these states of matter a little bit later on: solid, liquid, gas, and plasma. So here's one atom. Right now it's a little bit abstract, and I'm going to really nail this in at a later time, all the different parts of an atom. But just as a little preview, same as last year, you have this like nucleus type area here in the middle. It's made of protons and neutrons. And then you have this outer cloud, and that cloud has electrons in it. And then this is balanced like a magnet. The inside's positive, the outside's negative. We'll talk about it more in a later video. I don't want you to think about that too much today because we're learning about matter. So atoms are the smallest unit out there. Okay, think of Legos. Whether you're building an actual full-size house, or you're building a mini house for your little Lego guys, it all starts with one brick. Same thing here. The desk, you, the laptop, water, all starts with one single atom. That's the smallest we can break something down into. When atoms come together and combine, they form elements. Okay, so I have up in the front of my classroom the periodic table of elements. It's that dark black poster. Also over to the side near the windows, I have another periodic table of elements. So all of these elements on here, all 100 and something of them, all are made of atoms. So an element is a form of matter that contains only one type of atom. So back to that Lego house. If we would build a Lego house with only red bricks that had 8 little pegs, like the 4x2, that would essentially be an element. We used the exact same color, the exact same type of brick. So we combined atoms to make a Lego house, but we have to use the exact same ones. And hint for notes, I would write down these extra little hints that I'm trying to explain to you. So go back up to where it says atom and highlight or underline where it says one Lego brick. Down here where it says element, I would write in and add a bunch of red Lego bricks making a house. Okay, so that'll help you jog your memory later on. So a copper wire contains only copper atoms. A gold ring contains only gold atoms. And an oxygen tank contains only oxygen atoms. Here up in this picture, what you see is mercury. Mercury is very toxic to most animals that I can think of, especially to humans. Mercury is made up of only mercury atoms. And what's fun about mercury is that it's actually liquid at room temperature, and it's a metal. So we'll talk about that more, but it's pretty cool to look at. So here's an example. Here's that sodium atom from earlier. We have just one single Lego brick. Here is your one Lego brick. When we combine a bunch of these, we end up with this stuff here, sodium. Okay, sodium's just something that's used. It looks a little shiny, a little metallic. It actually hates water. Okay, so if you would drop sodium down into a cup of water, it'll jet around and it'll actually catch itself on fire. It hates water that badly. So when you're storing sodium, you actually have to be super careful because you cannot get it wet at all because it might start to explode actually. So atoms make elements, okay? Atoms, when they combine chemically, form new substances called compounds. And we're going to talk about two more key vocab words to get today. So when atoms combine, sometimes the properties of elements change. So I want to give you a real life example. Say you have a best friend and she starts to date this new guy. When all of a sudden she's a different person. She's not texting you, she breaks your Snapchat streak, she just doesn't really talk to you in the cafeteria anymore. Her properties have now changed because she has her new boo thing. Same thing here. Here's that sodium again. You just saw that explode in water. Sodium is a soft, shiny metal. Chlorine is used to clean pools. It's a greenish gas. I mean, just pretend you're smelling a pool. That's exactly what it smells like. But when you combine these two, sodium chloride, you get salt. Like the salt that you put on your French fries. So when we combine this soft, shiny, explosive metal and this green gas, it changes properties and it actually becomes this yummy seasoning that you can put on, if you're me, literally everything. So one way atoms combine is by sharing these electrons. So I know we haven't talked about them quite in detail yet, but all atoms have these electrons on the outside, and they're very easy to be shared. Okay, think of it, I mean, like anything, like your clothing. Your clothing's on the outside of your body, and it's very easy to share what you're wearing with people. People can walk up to you and see, oh, hey, I really like your blue shirt today, or your sweatshirt looks really comfortable. Okay, so it's the same thing. When atoms combine, they can also form molecules. So one example, two hydrogen atoms can share electrons with one oxygen atom and form one molecule of water. So hydrogen and oxygen, we're going to talk about this on another slide, are both gases. But when two hydrogens and one oxygen come together, they actually form liquid. That's the water you drink. Okay. So here's just a picture of that. Here's your two atoms of hydrogen. Okay, this is as small as it can get. We can't get a smaller piece of hydrogen right here. Here's one atom of oxygen. This is a gas. This is a gas. When we put them together, we actually get one molecule of water. So this would not be a drop of water, because a drop of water has a ton of molecules of water in it. So one molecule is like a super tiny nano drop of water. When many molecules of water combine, they form a compound. So we're going to try and differentiate these words in our heads because they're very similar. A compound is a type of matter that has properties different from each of the elements inside of it. So here's that example again. Hydrogen and oxygen are both gases normally, but when they combine, they form a liquid. Here's table salt. Here's that sodium, that explosive metal. Here's that chlorine or chloride, that green gas. When we combine it, here's your salt cube. You've probably salted something before. You can see that it's in a square, tiny little squares. Right there's why. That's how these things arrange. They make this perfect square structure every time they come together. Okay, so here's another one. Here's just another picture to see the same thing. Here's a hydrogen atom. Here's a hydrogen atom. Here's oxygen. This comes together, notice how they're sharing, to form water. Okay, so the white one goes with the hydrogen, the red one goes with the oxygen. They're sharing it so that it can become a water molecule. And in this case, a water compound. We're going to talk about that a little bit more. On Earth, matter occurs in 4 physical states: solid, liquid, gas, and something that you might not have heard of before called plasma. And I have 1 minute per slide, so here we go. Solids. Atoms or molecules are in a fixed position. They may vibrate, but they will not move. Okay, think of your desk. Your desk is a solid. Whether you believe it or not, all of the atoms inside of your desk are vibrating in place. They're always moving. You can't feel it. It's solid. It will never change shapes. The only way something's going to change with that desk is if something breaks it in half. Think of this as a completed puzzle. When you make a puzzle, a big 1,000-piece puzzle, the pieces are generally pretty stuck. Okay, they're not really going anywhere, but they can wiggle just a little bit. If you grab one piece and kind of twist it, it'll have a little movement, and you can grab the whole puzzle and spin it. That's also moving, but it's not really easy to take out one puzzle piece from the middle, and it's not really easy to move that one puzzle piece somewhere else because it's not going to fit. Solids, it has to fit in a certain way. Okay? They're being attracted to each other, and they are resisting being separated. They're actually stuck like that. Excuse me. So liquids are next. Liquids are atoms or molecules that are also strongly attracted to each other, just not as strongly as a solid. So think of a relationship. When you're solid with your boyfriend or you're solid with your girlfriend, you're good. You don't have to worry about them going out, looking at another boy, looking at another girl, anything. They're focused on you. Sure, they might still have friends of the opposite gender, but they're not pursuing another boyfriend or girlfriend. Liquids are a little bit shakier. They're that relationship that we're all kind of looking at being like, maybe it'll work out. Okay, they're free to move, and liquids flow. You know this. Liquids take the shape of their container. Sorry, I hit it too soon. So look at your water bottle. Look at my water bottle. Think of a pool, a river, a lake. It's liquid. It's still stuck together. You can't walk up and pick up one piece of water. It's stuck to all those other pieces. Okay, here's the thing of a bucket of water, a cup of water. When it's pouring in, you can see it splashing up. But for the most part here, even when it's coming up the side of the container, it's staying together. Water is attracted to water. And did you know cats are also liquid? Because cats also take the shape of their container. Now, I'm actually lying to you, but this cat was super cute. Okay. Almost last, gas. Atoms or molecules have very little attractive force on each other. Also, they don't really hold on, also known as they don't hold on to each other very strongly. So they're free to move. Think of when someone in your family is cooking and you smell that mac and cheese, or you smell that pie, or you smell those tacos, okay? That's wafting through the air. These atoms are moving evenly. I have that Scentsy, that wax melter in the back of my classroom, and you all always smell it and comment on how it smells like soap. I don't go around and waft it and move it around my classroom. It automatically does that because it's a gas and it wants to spread out evenly. So plasma. Most of the universe actually is in the plasma state. I read something that says 99% of the universe is plasma, not solid, liquid, or gas. So matter is comprised of ions and electrons. I'm just going to say that. I'm not even going to talk about it. We'll talk about it later on. Stars are composed of plasma. Lightning bolts are plasma. So all sorts of stuff. It has to do with how the electrons move, and it's in different states called an ion. So we'll talk about that a little bit later. We'll continue to practice this, but for right now, head back to Google Classroom and navigate to where you need to go next. If you have any questions or you get stuck, raise your hand and I'll come over and help you.